Now, the laws of indices provides a simple way in expressing numbers, especially when solving complex problems involving powers. Now, assuming you have the expression x exponent n. Now, this has been expressed in the index form. Now, from this, we have two components. We have the base and the exponent. Now, x is the base and then n is the exponent. Now, you can as well call n the power or the index. So let's say you have x exponent 2. Now, what this primarily means is that you want to multiply x 2 times. So this is equal to x times x. If you have a exponent 3, it means that you want to multiply a 3 times. So that is going to be a times a times a. If you have 2 exponent 4, it means that you are going to multiply 2 4 times, which is 2 times 2 times 2 times 2. So this is basically an introduction. Let's move ahead and talk about some other laws of indices. So now let's talk about the first law. Now, for the first law, any non-zero number or variable raised to the power 0 is equal to 1. Assuming we have x exponent 0. Now, this is equal to 1. If we have 2 exponent 0, this is also equal to 1. If we have 100 exponent 0, that is equal to 1. Now, this law stands provided x is not equal to 0. Now, if x is equal to 0, it makes the expression undefined. So 0 exponent 0 is not equal to 1, and that is undefined. Now, let's talk about the second law. So for the second law, if you have x exponent m times x exponent n, then that is equal to x exponent m plus n. Now, what this primarily means is that if you want to multiply indices of the same base, then you want to add their exponents. So x exponent m times x exponent n is equal to x exponent m plus n. So for example, if you have 2 exponent 2 times 2 exponent 4, then that is 2 exponent 2 plus 4, which is equal to 2 exponent 6. Let's say you have 3 exponent 4 times 3 exponent 9, then this is equal to 3 exponent, now 4 plus 9 is equal to 13, so you have 3 exponent 13. Now let's talk about the third law. So let's say you have x exponent m, and then you divide by x exponent n. Now this is equal to x exponent m minus n. If you want to divide indices of the same base, then you want to subtract their exponents. So x exponent m divided by x exponent n is equal to x exponent m minus n. So if you have 10 exponent 3 divided by 10 exponent 1, then it's basically 10 exponent 3 minus 1, which is equal to 10 exponent 2. Now let's talk about the fourth law. Now if you have x exponent m, all exponents n, then you want to multiply the exponents. So that is going to be x exponent m times n. For example, if you have 2 exponent 3, all exponents 2, it means that you are going to multiply 3 and 2. So that's going to be 2 exponent 6. So for law 5, if you have x exponent negative n, now this is equal to 1 over x exponent n, provided x is not equal to 0. Now if you have 2 exponent negative 1, then that is equal to 1 over 2 exponent 1, which is equal to 1 over 2. Now for law 6, if you have x, y exponent n, then this is equal to x exponent n times y exponent n. So if you have 2 times 3 exponent 2, then this is equal to 2 exponent 2 times 3 exponent 2. Now let's move on and talk about the 7th law. Now, let's say you have x over y, all exponents n. Now this is equal to x exponent n divided by y exponent n, where y is not equal to 0. If y is equal to 0, it makes the function undefined, or the expression undefined. So let's say you have 2 over 5, all exponents 2. Now this is equal to 2 exponent 2 divided by 5 exponent 2. Now 2 exponent 2 is 4, and then 5 exponent 2 is 25. Now for law 8, if you have x over y, all exponents negative n, then basically you want to interchange the positions of x and y, and then you make negative n and x, then you make negative n a positive exponent. So that is y over x, and then negative n becomes positive n. Now assuming you have 3 over 4, all exponents negative 2. So you are going to interchange the positions of 4 and 3. So that is 4 divided by 3, and then you have exponent 2. Now 4 exponent 2 is 4 times 4, which is 16. And then 3 exponent 2 is 3 times 3, which is 9. Now this law will stand provided both x and y are not equal to 0. Now we are going to conclude this section with law 9. So for law 9, if you have x exponent m divided by n, then that is equal to x exponent m, and then we have n here. Now let's try with an example. Let's say you have 8 exponent 2 over 3. Using this approach, then we have 8 inside here, exponent 2, and then we have 3 on the outside. Now let's simplify. 8 squared is 8 times 8, which is 64. So we have 64. So basically, this is the cube root of 64. So the cube root of 64 is equal to 4. So this is the answer. Now, if you have 2 exponents 1 over 2, then it's equal to the square root of 2. If you have 3 exponents 1 over 3, then it's equal to the cube root of 3. And then if you have 4 exponents 1 over 4, then this is equal to the 4th root of 4. Now from this law, we realize that 2 exponents 1 over 2 is equal to, we have the square root of 2 exponent 1, and then we have 2 on the outside. But because we don't normally write 2 if we have the square root, that is why we ignore this. So it is equal to the square root of 2, which is what we have here.